Hello, my name is Kindson Munonye, and welcome as we start our discussion of this new knowledge area, and that is project quality management. Previously, we completed our discussion on the project cost management knowledge area when we discussed the control costs. So let's now look at project quality management. One thing I want you to bear in mind is that quality management is critical to the success or failure of the project. So attention has to be given on quality management because if the project fails to meet the quality requirement, it's as good as the project being a failed project. So what is project quality management? Project quality management includes the processes and activities of the performing organization that determine quality policies, objectives, and responsibilities so that the project will satisfy the need for which it was undertaken. Project quality management uses policies and procedures to implement within the project's context the organization's quality management system, and as appropriate, it supports continuous process improvement activities as undertaken on behalf of the performing organization. What I'm mentioning here is things we are going to explain at a later time. Take note of this important term, continuous process improvement. Alright, project quality management works to ensure that the project requirements, including product requirements, are met and validated. When we talk of project quality management, it has to do with the meeting of the requirements of the process or even the product. There are three management processes or three processes under the quality management process knowledge area. One of them is plan quality management, which is what we are going to discuss in this particular presentation, and that is the process of identifying quality requirements and standards for the project and its deliverables, and documenting how the project will demonstrate compliance with quality requirements. The second process in quality management knowledge area is perform quality assurance. It is a process of auditing the quality requirements and the results from quality control measurements to ensure that appropriate quality standards and operational definitions are used. Take note of the keyword auditing. When we mention quality assurance, think about auditing. And finally, we have control quality as a process of monitoring and recording results. We hear of control, think of monitoring, measuring, and recording. Alright, let's continue and look at these concepts of quality and grade. Quality and grade are two different things altogether. Low quality is a concept used. We also have low grade. But how does this relate and what is the difference between them? Well, quality as a delivered performance or results is the degree to which a set of inherent characteristics fulfills requirements. So we are saying that some activities have certain requirements, and quality means you have to fulfill this requirement. Let me just think of a wild example to give. Just take for instance that a meeting start time and close time is 10 o'clock to 3 o'clock, and that is a requirement. It means that coming by 10 o'clock is the start time, and then you have to stay till 3. It means that abiding by this means that you are getting it right. If you have to come by 8 as required by some certain organizations or schools as a norm, that is not what is required in this particular case. So what we are saying is defined requirements, meeting up to it is what quality is all about. Let's now look at grade. Grade as a design intent is a category assigned to deliverables having the same functional use but different technical characteristics. Let me think of an example. Think of an iPhone 6 and also think of a Nokia Touch. These are two different phones used for making calls but of different grades. Or let me just say iPhone 4X and iPhone 6X. They are two different iPhones of high quality but different grades. Meaning that if you have a higher grade, it doesn't mean low quality, but it means higher features. The higher the grade, the higher the number of features, maybe the same quality. The lower the grade, the lower the number of features, but maybe the same quality. And now what is the problem? While a quality level that fails to meet quality requirement is always a problem, a low grade of quality may not be a problem. I hope you understand this. If not, spend some time here and get this around your head. Let's now look at another two concepts of accuracy and precision. Precision is a measure of exactness. For example, the magnitude for each increment on the measurement number line is the interval that determines the measurement's precision. The greater the number of increments, the greater the precision. Meaning that how close are successive measurements related to each other, right? That is precision. Accuracy is the assessment of correctness, right? For example, if a measured value of an item is very close to the true value of the characteristic being measured, the measurement is more accurate. Let's move on to discuss approaches to quality management used today. So, modern approaches to quality management recognizes importance of customer satisfaction, which means understanding and defining and managing requirements so that customer expectations are met. Prevention of over-inspection. Quality should be planned, designed and built into, not inspected into. Meaning that the work of the project should gear towards meeting up the quality requirement. It should not be inspected to check whether it meets up, and if it's not, doing a correction. But the focus should be meeting up the requirement initially. We also have continuous improvement, which was mentioned by Deming. Plan, do, check, act cycle, the basis of quality improvement. So it's a continuous improvement. You plan, you do, you checked, you continue again. You repeat the process. We also have management responsibility is also recognized in approaches to quality management. Cost of quality. Cost of quality, we mentioned it during the estimate cost process. That is the total cost of conformance to work and non-conformance work that should be done as a compensatory effort because of the first attempt to perform the work. On the first attempt, the potential exists that some portion of the required work effort may not be done or has not been done correctly. What is continuous improvement? The PDCA cycle is a basis for quality improvement as defined by Showhart and modified by Deming. In addition, quality improvement initiatives such as Total Quality Management, Six Sigma, and Lean Six Sigma will improve the quality of the project management as well as the quality of the project's product. Commonly used process improvement models include Malcolm-Bridge, Organizational Process Management Maturity Model, OPM 3, that's Organizational Project Management Maturity Model, Capability Maturity Model Integrated. All of these are process improvement models. We also mention cost of quality, and this refers to the total cost of the conformance work and the non-conformance work that should be done as a compensatory effort because on the first attempt to perform the work, the potential exists that some portion of the required work effort may be done or has been done incorrectly. The cost of quality may be incurred throughout the deliverables life cycle. For example, decisions made by the project team can impact the operational costs associated with using a completed deliverable. Post-project quality costs may be incurred because of project returns, warranty claims, and recall campaigns. Okay, having discussed this background concepts, let's now go to the first process of the quality management knowledge area, and that is plan quality management. Plan quality management is a process of identifying quality requirements and standards for the project and its deliverables, and documenting how the project will demonstrate compliance with relevant quality requirements. The key benefit of this process is that it provides guidance and direction on how quality will be managed and validated throughout the project. Alright, quality planning techniques will be discussed next. But before then, let's look at the ITTOs of plan quality management. We have 6 inputs, and that is project management plan, risk register, requirement documentation, enterprise environmental factors, and organizational process assets. Tools and techniques are cost-benefit analysis, cost of quality, 7 basic quality tools, benchmarking, design of experiments, statistical sampling, additional quality planning tools, and meetings. The outputs of plan quality management include the quality management plan, process improvement plan, quality metrics, quality checklists, and project document updates. Let's take a closer look at these ITTOs, and it becomes clearer why we need these input tools and techniques and outputs for plan quality management. We have the first one, and that is the project management plan. The project management plan is used to develop the quality management plan. The information used for the development of the quality management plan include the scope baseline, the schedule baseline, the cost baseline, and other management plans. Remember, the baselines and subsidiary management plan come together to make up the project management plan. Remember that aspects of the project management plan include the requirements management plan and the process improvement plan. Another input to plan quality management is the risk register. The risk register is necessary because it contains information on threats and opportunities that may impact quality requirements. We also have the stakeholder register. The stakeholder register aids in identifying those stakeholders possessing a particular interest in or having an impact on quality. Then we also need requirements documentation. Requirement documentation captures the requirements that the project shall meet pertaining to stakeholder expectations. The components of the requirement documentation include, but are not limited to, project and quality requirements. The requirements are used by the project team to help plan how quality control will be implemented on the project. To plan quality management, we also need the enterprise environmental factors. Some of them that can affect quality planning include government agency regulations, rules, standards, and guidelines specific to application area, working or operating conditions of the project, and cultural perceptions that may influence expectation about quality. We also have some organizational process assets that might impact on plan quality. For instance, historical databases and lessons learned from previous projects or phases of the project, and organizational quality policies, procedures, and guidelines. Alright, let's now look at these 7 tools and techniques of plan quality management. The first one is a cost-benefit analysis. Just a second. Okay. the cost-benefit analysis. The primary benefits of meeting quality requirements include less work, higher productivity, lower costs, increased stakeholder satisfaction, and increased profitability. Cost-benefit analysis for each quality activity compares the cost of the quality step with the expected benefit. Okay, let's now take a closer look of this second tool and technique, and that is cost of quality. Cost of quality has been discussed previously in estimate costs and determine budget. Includes all costs incurred over the life of the project by investment in preventing non-conformance to requirements, appraising the product or service for conformance to requirements, and failing to meet requirements, that is rework. Of course, project managers should as much as possible avoid rework or costs of failure. Failure costs are often categorized by internal and external failures. Failure costs are also called costs of poor quality. I'm also displaying this screen from the Pinboard Guide 5 to help you understand the cost of quality. It's categorized into two: cost of conformance and cost of non-conformance. Let's now look at another tool and technique for plant quality management, and that is the 7 basic quality tools. Let's now look at them one by one. You might find a way to memorize these 7 tools. One of them is cause and effect diagram, also known as fishbone diagrams or Ishikawa diagrams. The problem statement is placed at the head of the fishbone and is used as starting point to trace the problem source back to actionable root cause. Fishbone diagrams often prove useful in linking the undesirable effect seen as special variation to the assignable cost, upon which project teams should implement corrective actions to eliminate the special variations detected in a control chart. The second of the 7 basic quality tools is a flowchart, also known as process maps. This represents inputs, process, decisions, output, and other items using symbols like the rectangle, the kite, or the parallelogram, and the circle, and other items. Other things are used to represent processes, input, output, decisions, branches, and so on. We have check sheets, the third of the 7 basic quality tools, also known as tally sheets, are used to organize facts in a manner that will facilitate the effective collection of useful data about a potential quality problem. They are especially useful for gathering attributes data while performing inspections to identify defects. 4. Pareto charts. A special form of vertical bar charts are used to identify the vital few sources that are responsible for causing most of the problem effects. Alright, let's move to the next one. Histograms, a special form of bar charts, are used to describe the central tendency, dispersion, and shape of statistical distribution. Unlike control charts, the histogram does not consider the influence of time on the variation that exists within a distribution. Control charts are used to determine whether or not a process is stable or has predictable performance. A control chart is used to determine whether a process is out of control or is within control. A process is considered out of control when a data point exceeds a control limit, or when 7 consecutive plot points are above the mean, or 7 consecutive plot points are below the mean. And the 7th of the 7 basic quality tools are is the scatter diagram. Plot ordered pairs of x and y are sometimes called correlation charts because they seek to explain a change in the dependent variable y in relationship to a change in observed value of the independent variable x. Another tool and technique used for quality planning is benchmarking. Benchmarking involves comparing actual or planned project activities to those of comparable projects to identify best practices, generate ideas for improvement, and provide a basis for measuring performance. Benchmarked projects may exist within the performing organization or outside of it, or it can be within the same application area. Benchmarking allows for analogies from projects in a different application area to be made. Let's continue to the next tool and techniques for plant quality management, and that is design of experiments. The design of experiments is a statistical method for identifying which factors may influence specific variables of a product or process under development or in production. Design of experiment may be used during plant quality management process to determine the number and type of tests and their impact on cost of quality. Design of experiment plays a role in optimizing products or processes. Design of experiment is used to reduce the sensitivity of product performance to sources of variations caused by environmental or manufacturing differences. One important aspect of this technique is that it provides a statistical framework for systematically changing all of the important factors rather than changing the factors one at a time. And then we have another tool and technique used in plant quality is additional quality planning tools. I have brainstorming, force field analysis, diagrams of the forces for and against change, nominal group techniques, quality management, and control tools. Having discussed all of these tools and techniques of plant quality management, let's now look at outputs of plant quality management. We have the quality management plan. This is a component of the project management plan and describes how the organization's quality policies will be implemented. The quality management plan describes how the project management team plans to meet the quality requirement set for the project. We also have the project improvement plan. I've decided to explain a little more on the project improvement plan. The project improvement plan details the steps for analyzing project management and product development processes to identify activities that enhance their value. For process improvement plan, areas to consider include process boundaries, process configuration, and process metrics, and target for improved performance. Another output of the plant quality management is quality metric. The quality metric specifically describes a project or product attribute and how the control quality process will measure it. A measurement is an actual value. The tolerance defines the allowable variation to the metric. For example, if the quality objective is to stay within the approved budget by 10%, the specific quality metric is used to measure the cost of every deliverable and determine the percent variance from the approved budget for that deliverable. Quality metrics are used in perform quality assurance and control quality processes. Some examples of quality metric include on-time performance, cost control, defect frequency, failure rate, availability, reliability, and test coverage. So on this note, we wrap it up on the projects on plant quality management, the first process under the quality management project quality management knowledge area. I hope this has been informative for you. By way of advice, I'll say you may have to rewind this video, go back to various tools and techniques we've discussed and the various inputs and outputs of the plant quality management. Thanks a lot for viewing, and please do join me in my next presentation, as I'm going to discuss the second process on the project quality management knowledge area, and that will be perform quality assurance.